All right, so today we're going to combine, and really, with the exception of the lecture for 9-6, we're going to combine all the different transformations we looked at so far, which are all rigid. So we've talked about translations, rotations, reflections, and what's the fourth one? The glide reflection. All of those give you rigid motions, meaning that they preserve distance and angles. And so look at your vocab, super easy part. Answer 1 and 2 for me, please. And note that they did give you a triangle congruence statement right here, so it should tell you whether these triangles here are oriented correctly. So you do want to check that before you assume that side AB corresponds to side DE. Do they? Here's AB, and doesn't DE come in the same order? So they do correspond. All right, so would we all agree that those are the solutions to 1 and 2?
Yes.
Perfect. So then, look at what we're looking at today, congruent. I mean, we've used congruent all along. Two figures are congruent if and only if there's a sequence of rigid motions that maps, so a sequence of rigid motions that maps one figure onto the other. So it's a slightly different definition of congruency that they're using here. And we studied isometry, which is one or more rigid motions. And so that's any combination of the translations, rotations, reflections, and then of course the glide reflection is already a combination in itself. So circle the number 3, circle the transformations that make up a glide reflection. What makes it up? What's the glide part? Translation. Obviously the reflection is a reflection. And then number 4, when a figure is transformed by an isometry, what is true about the corresponding angles and the corresponding sides of the image and preimage? So I already talked about that. What's true? They're congruent. So corresponding sides and angles are congruent. And you might want to put a note here, isometry preserves distance and angles. All right, so let's look at page 2. So for example 1, they've given you a composition here. Which one comes first? What is this one? A translation, rotation, reflection. That's a rotation? That's a reflection over, what's this mean? What's T? Line T, because it's a lowercase cursive letter, so that represents a line. And then what does this mean? Translation, what? To right and up 3. So which one of these must occur first? The second one occurs first. So, they're telling you right here that this is the preimage, and then this is the image. So you're going to start with triangle ABC, and you're going to end up with triangle XYZ. And notice that they started with ABC, that they have this A prime, B prime, C prime, because that's the interim step. And then they've got this. So this is your translation of 2 to the right and 3 up, and then they reflected it over this line T. And so we end up with this image. So compositions of isometries preserve angle measures, so corresponding angles have equal measure. Fill in the blanks to make the true statements. So angle A corresponds to which angle? X. And angle B corresponds to Y. And angle C by a process of elimination, it must be z. Also, by definition, isometries preserve distance, so corresponding side lengths have equal measures. Draw line segments to match the corresponding side lengths. So side AB corresponds to what side? XY. And then BC corresponds to what side? YZ. And so that leaves AC corresponding to XC. So super tough so far, right?
Yeah, I'm lost already.
You're lost already. Are you being funny?
Yes.
Okay, good. Just checking. All right, so key concept. Two figures are congruent if and only if there is a sequence of one or more rigid motions that maps one figure onto the other. So there's that same definition. That's all you're working with today. So problem 2. They've kind of made it a little bit more complicated than it needs to be, but let's go ahead and walk through this. Which pairs of figures in the grid are congruent? So they've got 4 figures in that grid. Obviously, you could match up figures pretty easily, right? Because this is how many sides? 4, and that's how many sides. So obviously these two must go together, and those two must go together. But here's your job, and this is what some of you are going to struggle with, is what happened from here to here, and what happened from here to here. That's what you're going to have to decide. And did one transformation occur or more than one? And so let's look at the parallelogram ABCD maps onto parallelogram HIJK. So that's obvious. So what did we do? Just pick a point. So let's pick point A. What point corresponds to A from here to here? It's going to be obvious if you look at this from here to here. What H. So these are the two corresponding points. What happened to get us from A to H? So could I move 1, 2, 3, 4, 5, 6 to the right and 1, 2, 3, 4, 5 down?
Yes.
Does that work for every one of those? D corresponds to K, right? So D is also 1, 2, 3, 4, 5, 6, and down 1, 2, 3, 4, 5. So if you did that for all of them, it seems that that's reasonable. And then I would definitely check for all 4 vertices. And so fill in what they have here to the right. To map the parallelograms, translate ABCD. What did we say? How many units to the right? So 6 units to the right. And how many units down? Was it 5 units down? 5 units down. Number 8's a little bit more difficult to map UVW onto QNM. So we're going from here to here. So obviously U corresponds to Q, right? Those correspond. And if I just do a translation, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. 6 to the left, 6 down. Does that work for V and N? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. That didn't work, did it? So it can't be a translation. So what might have happened? Perhaps a reflection or a rotation? Well, I know they tell you that, but they're not going to tell you that normally, right? So, I mean, obviously, yeah, they've got, okay, they reflected across, and then they're telling you it's a translation. So here's what you're going to have to do. You're going to have to do a little bit of pencil work where you might try something and scratch it out and try something else. So you might try a reflection this way first or a reflection this way. Yeah, you might reflect over and it's not always going to be a reflection over the X or the Y axis. Sometimes it's a reflection over, maybe X equals -1. Or a reflection over Y equals -1. So watch that as you're doing this. So they do walk you through it a little bit. So we reflect UVW across Y equals. So they're kind of giving you a hint across Y equals. Y equals is what kind of line? Horizontal. And so find the distance between two corresponding points. So we identified these as our two corresponding points. How far apart are they vertically? Because our y line is going to go in this direction. So I want to find their distance vertically from each other. So if I go over here, didn't we say that it was 6 apart earlier? Right? So what's half of 6? 3. So if I went down from here, I'm trying to get it right on there. So if I went down from here, 1, 2, 3, that's y equals what? 0, which is really the x-axis, but that's y equals 0. So I'm going to put a line, a green line, right here, the y equals 0, because I always like to do that. You can put a highlighter through there so you can visually see that distance, and then you can go ahead and plot those points. So I'm going to plot the reflection of, because UVW is our original, so I'm going to plot the reflection. U is 1, 2, 3 away, so we're going to go 1, 2, 3 on the other side. So I'm going to plot this point right here as U prime, and then V is 1, 2, 3, 4 away, so we want to go 1, 2, 3, 4 over here. So this right here is V prime. And then W is 1 away, so we want to go 1 away here. And so this becomes W prime. And so if I connected those with a straight edge, of course, now do you see that we would just translate it over this direction? So for those of you who are having visual issues, it's really important that you try to perform certain rotations or reflections or translations and then see what could happen to get to the other one. So then from here, all I have to do is go, 1, 2, 3, 4, 5, 6 to the left, right? Nothing up or down. So go ahead and fill out what's left here. So we had y equals 0, and we want to write that in here, by the way, y equals 0. Bless you. And then we translated triangle UVW 6 units left and nothing down. So now we're going to actually find describe our rules or our transformations that occurred. So for number 9, now they're talking about the quadrilaterals again. So we had just one transformation that occurred. We went 6 to the right and 5 down. So what goes here? The right or the down? Right. The right is your x direction. So with 6 to the right, is that a positive 6 or a negative 6? So positive 6. And then with the 5 down, positive 5 or negative 5? Negative 5. And the parallelograms are congruent is what they're looking for. And then for this one, note that this is the transformation that occurred first, was the reflection. And they wrote y equals 0. You're more than welcome to write x-axis if you prefer. That's fine as well. And then the second thing that occurred was our transformation or our translation, and we only went 6 to the left.
So, 6, 0.
Well, 6 to the left, is it a positive 6 or a negative 6?
Negative.
So negative 6, and then yes, 0 would be there because we did not go up or down. And then this one they left this blank. This was the pre-image. What was our image? So this was our pre-image. Yeah, QNM is our image, so we need to put that in there. Triangle QNM, and the triangles are congruent. Then problem 3, they make much more really needs to be. So we're essentially going to ignore a lot of this page, but we're just going to do the work up here. So here you have one triangle that mapped onto another. So they've told you that NAV right here maps to BCY. So this is your pre-image, and then this is your image. Tatum, darling, your head needs to be off the desk. And so let's look at NAV. And we're going to have to do some thoughts as to what might have occurred. So as I'm looking at NAV, I could have rotated it over here. I'm not sure. So if it rotated, it's possible that this could be the point of rotation, the origin, because that's generally something that we would rotate around. So if I did that, I know that N corresponds to what letter on the other triangle? B. So I would want to look at N and B. So I would want to connect a line from N to V, and then from V to B. Does that look like a 90 or a 180 degree rotation or anything like that? No. And so that's not going to be a rotation that you're expected to figure out on your own. So the only ones that you'd have to figure out that it was rotation would be 90 degrees, 180, or 270. So if it doesn't look like it's had a right angle in there, then it's probably not a rotation. So we're going to cancel out that thought. So let's remove those. That's why you want to be using a pencil so you can erase. Then your next thought might be, maybe I could reflect. So if I look at N and B, what's the distance between N and B? This way. Because maybe I'll reflect over a vertical line. So how far is N and B from each other? Here's N coming down here. So I've got what? 1, 2, 3, 4, 5. Well, what's half of 5?
2.5.
Yeah, 2.5. So it's probably not going to be a reflection here, but it's possible that we could reflect over the y-axis. Let's look to see what happens if we reflect over the y-axis. So N is 1 unit away here, and we would put N 1 unit away here. So this would become N prime. And then V is on that line of reflection, so it stays itself. And then A is 1, 2, 3, 4 away, so we want to go 1, 2, 3, 4 over here. And this becomes A prime. Danny, pick that up. And so then, how could I get from here to here? Yeah, so this A right here corresponds to C. So to go from A to C, we could go down, we could reflect, but I doubt that that's what it is because A and C won't reflect that direction, right? So maybe it's a translation. 1, 2, 3, 4, 5, 6. 1, 2, 3. Okay, so 6 down, 3 to the right. What about N and B? Does that work? 1, 2, 3. Was that the same as before? No. So it cannot be a reflection with a translation. So again, that's a scratch. Well, we're going to try that next. So Ian said, well, maybe we'll reflect over the x-axis. I don't know, let's try that. So if we reflect over the x-axis, here's your x-axis, right? So V is 1 unit away, so wouldn't V prime be here? A is 3 units away, so A prime would be here. And then N is 5 units away, so N prime would be here. And so don't forget that N corresponds to B, so here's N and B. So we could go left, 1, 2, 3, 4, 5, that works. And then V corresponds to Y, so we would go left, 1, 2, 3, 4, 5. So far, so good, right? And then A corresponds to C, 1, 2, 3, 4, 5. Did that work?
Yeah.
So here's what we did. We reflected over the x-axis. So that was number 1. And then number 2, we translated how many? 5, what direction? Left. And no up or down. So we don't need all this gobbledygook that they have in here, do we? So we're going to take all of this and we're going to X it out because this is way more confusing than it needed to be. And the other thing I'm going to point out to you is, well, how did you know you reflected over the x-axis? Because it could have been any other horizontal line. So look at the distance between N and B again. So the distance from N all the way to B. What was that distance? Vertically. 5 here and 5 here. What's half of 10? 5. So half of 10 is 5. That's this line cuts it nicely in half, unlike the distance horizontally between them was not a nice line. So that's how you know. Look at the distance between two corresponding points and count that distance and see if you have a nice half line that you can draw between them. And then that would be a line of reflection, because remember, they're equal distance apart from that line of reflection. So it just so happened that this one was the x-axis. So then down here, which of the following out of these 4 on number 14, which of these 4 is the proper transformation, which is an isometry? The second one, let's see. Is this the one that we did first? Yes, and so it should come second. And then is this showing 5 to the left? Yes. So this is the correct translation rule or transformation rule. Then look at page 4. Here's how you're going to remember that you know and love me. Verifying. What does that mean?
Yay!
Right? Right. So we're not going to do proofs in this particular section. All right? So last thing I want you to do is a lesson check. You're going to do the lesson check on your own. I want you to share your answers with those around you. Okay, is she ready? Uh-oh. I've lost my... What do I do with my little pen?
It's under there. It's under the...
Oh, thank you. Okay, so let's answer the questions. What are the 4 isometries? Rotation. Reflection. Translation. They didn't give you a whole lot of room. And glide reflection. So those are your 4. The composition of 2 or more isometries is an?
Isometry.
It is. Weird but true.
Put isometry.
Well, it seems weird. It's like, should it be a different word, right? Is a composition of a rotation followed by a glide reflection a congruence transformation? Yes or no?
Yes.
Since, and you can write it this way, since both a rotation and, need a little space in between there, and a glide reflection are isometries, meaning they preserve distance and angles, then with an I, who spells then with an I? Then
You get it.
they are a congruence transformation.